12.2, the surface area of prisms and cylinders. All right. Important to know today we're doing surface area. So this is the area that covers the surface of a prism or cylinder. So a prism we talked about in 12.1 has two congruent bases, often parallel to each other, joined by those rectangles, okay? So I have a picture of a prism over here. In this case, my two congruent bases are these trapezoids here on the top and the bottom. Those are my two bases, and they're joined by rectangles. And n is the number of sides of the base. So if there's 4 sides here on the base, then I have 4 rectangles around there. Now, on this particular trapezoidal prism, there are not equal or congruent rectangles, but they're all 4 rectangles, okay? So my lateral faces, and this is important, these are the rectangles of the prism, okay? So those are the ones that hold the bases together. Those are the all the rectangles together. The lateral edges are the edges of these, okay? And what's important to know is this edge is also what would be called the height of the prism. So if we're asked for the height, which we will be in our formulas, that any one of these lateral edges are the same length, and they are going to be the height of the prism. So the surface area is the total area of all the faces of a polyhedron, and the lateral area is just the lateral faces, the rectangles, okay? When we get into pyramids later, it will be the triangles, but while we're doing these lateral area of the prisms, it's all the rectangles, okay? So the surface area includes the bases, okay? That's what's important here, includes the bases, and the lateral area, no bases, okay? So that's really the difference between these two. So when you think about it, which number is bigger, surface area or lateral area? It would be the surface area because there's more to it because there's 2 more bases involved. All right, a net is a 2-dimensional representation of the faces of a solid. Okay, if you were able to, before we started 12.1, create a 3-dimensional object using this, you were given a net, okay? So something might be, let's see, if I had a pentagonal prism, well, this is not going to be a pentagon. How about a hexagonal prism? My net might look like this, where I had rectangles coming off of each one, okay? They were all spread out like this, and then maybe hooked onto one of them, I have another hexagon for my second base. So that would be a net. If I cut it out and I glue it together and I fold it, I could make a prism, a hexagonal prism with the rectangles joining them and the 2 hexagons that are the bases, okay? So a net is a 2-dimensional representation of the faces of a solid. We cut it out, we can work with it, but it's going to be important as we do surface area today to kind of visualize these nets at times. Okay. A right prism, and this is basically what we work with here in geometry, are going to be right prisms. Every lateral edge of the prism is perpendicular to the base. So these are going to be something that is straight up and down from each other, okay? So you have a triangular base here, a triangular base here, and when you join these, all of these are 90 degrees from the each base. So you're going to have these perfect, I shouldn't say perfect, you're going to have these rectangles in between them because it's a right prism. Oblique, the hardest thing here is trying to figure out how to draw an oblique prism. It basically means, I can show it better in real life, in person, is you don't have your edges perpendicular to the bases. So something's been like slanted, someone's been squished, okay? And it forms this oblique prism. So oblique is anything that's not right, okay? And I don't mean like, you know, as far as no right angles, okay? That's what I mean for an oblique. All right, a cylinder is a solid with congruent circular bases, okay? So if you think about it, you have the 2 circles on top and bottom, and you join them up there. That is the cylinder. A right cylinder whose segment joining the center of the bases is perpendicular, so it means you're just 90 degrees here, okay? Most of everything we deal with will be a right cylinder, but there could be slants, especially something that, you know, if you have something that's a pipe and that has a slant to it, so that might not be a right prism, okay? Sometimes a straw appears to not be a right prism depending on how it's cut and such to be used in a cup. So those, a right prism and a right cylinder are what we're going to deal with, but there are other ones, and those oblique ones do not fit the equations we're going to use, okay? All right, page 2. Sometimes it's easier to just do this and show more of it than just go through the definitions. Okay, so the surface area of a right prism is 2 times the big B plus P times H, okay? Or it says A times big P plus P times H. All right, this is what we have to think of. What we have are 2 bases, okay? So whatever the shape is of those bases, we need to find their area and double it, okay? So that's where this big B is. It's so important we realize that this big B means area of the base, okay? It's why we don't have a little b. Little b stands for like the bottom, the base of a triangle, the base of a rectangle, the base of a parallelogram, the bases B1 and B2 of a trapezoid, that little b. But when we see this big B, it means the area of the base. So we might have to do work to find this big B, and there's 2 of them. Then we're going to find P times H. Now big P means perimeter. Excuse my spelling there because I can't spell very well. How about perimeter of the base? Okay, so it's finding all the edges of the base. And then the H stands for the height, and this is important because sometimes the bases have a height. This is the height of the prism. Okay, so remember, that's that lateral edge that goes from edge to edge, okay, to see how high it is. That's what those 3 letters mean, and it's super important you know that because we are going to use that as our formula. So when I say surface area is 2 big B plus P times H, that will cover every prism we have, okay, as long as we can find the different big B's and the different P's, okay? And you'll notice I put this extra little note down here too. We can follow this one, or, sorry about that, we can draw the net and find the area of each shape separately, because that's always an option as well. And sometimes it's easier to do that because we see this. Okay, so there is this second equation over here, the A times big P plus P times H. That's just saying if you have a regular polygon. And we used 1/2 A times P when we did regular polygons back in 11.6. But to be honest, if we just use this one on the left for everything, it'll cover everything and we'll do fine with it. Okay, so let's look first at surface area of a right prism here. All right. This question always cracks me up because they throw a new formula in here that the book has never talked about before, but they use it here and they've never shown it before. Now, again, this is going to depend on if I gave you this worksheet right after Chapter 11 test, which sometimes I do and sometimes I don't, so it might be something we look at there. But there are different formulas for a triangle, and if you happen to have a equilateral triangle, this equation works, but it only works for an equilateral triangle, okay? So here's the equation. Area equals, I usually write it s squared radical 3 over 4, and it works only for an equilateral triangle. So if you know the sides, which in this case, all of these sides right here are 6, 6, and 6, okay? So I can plug in 6 for the side times radical 3 over 4. 6 squared is 36. 36 divided by 4 is 9, so I can get a big area here of 9 square root of 3. Okay, so that's what this one is getting you. And that's going to be my big B because it's the area of the base, okay? By the way, if you would have used that as 1/2 apothem times perimeter, you would have got this same thing. If you would have dropped the altitude down and worked on 1/2 base times height, you would have got the same thing. All of them would get you the same thing. So we get this 9 square root of 3, and that's for these 2 triangles on either side, okay? Then we have the rectangles. I'm going to show you kind of the net for this one. I'm going to draw this one a little bit differently, okay? So that's supposed to be a triangle there. 3 rectangles and a triangle again, okay? So that's what we have here. So we just found these 2 bases are both 9 square root of 3, and now we have 3 rectangles that we're going to find. Well, all of the rectangles have this height of 8. That's my H, okay? So where this P comes in at is if we could find the perimeter of this triangle, which, by the way, is 6, 6, and 6, right? I can also take this 6 here and this 6 over here to here, and I get all these rectangles that are 6 by 8, 6 by 8, and 6 by 8. So what they're telling you is whatever your base is, if you can find its perimeter and multiply by the height, it'll take care of all your rectangles together at the same time. So the perimeter here is 6 plus 6 plus 6, which is going to give me 18, and then my height. Okay, so if you can find a big B, you can find a P, and you can find the height, you can go ahead and find your surface area. So I'm going to do 2 times 9 square root of 3 plus my perimeter of 18 times my height of 8. Well, 2 times 9 radical 13, or radical 3, sorry, will give me 18 radical 3. 18 times 8 here will give me 144. And if I wanted to leave this in simplest radical form, I would just put my inches squared right there because I'm finding area, okay? Obviously, though, if I need paint to paint this, I wouldn't go in and say, I need 18 radical 3 plus 144 inches squared to paint. No, that's not what you do. So you can just plug that into your calculator, and it comes out to about 175.2 square inches. All right. Surface area of a right rectangular prism with height of 5, length of 11, and width of 4. Okay, I'm going to draw this. A right rectangular prism, otherwise known as a box. Okay, so I have a height of 5 feet, length of 11 feet, and width of 4 feet. And I'm going to be honest, it doesn't matter where you label those. Okay, don't forget there are how many sides on a box? There's 6 of them. Okay. If I talk about right now the front of this box and the back of this box, they're going to be 11 across, and they're going to be 5 high, okay? So that's 5 high. So that's 2 of them, okay? Then if I talk about the sides of the box, okay, the left and right side, I'm going to just kind of highlight here. So I'm doing this side and then this side over here right now, okay? That's going to be a rectangle of 4 across and 5 up, 4 across and 5 up. Okay, and then finally, if I do top and bottom, so let me change my colors here. So the bottom would be this one right here, and then the top up here. So if I do both of those, they're going to be 2 rectangles of 11 by 4 and 11 by 4. Okay. That's if I separated this all out, you could see those 6 different surfaces, okay? What I want you to see right here is there's 2 of them that are 11 times 5, okay? And then there's 2 of them that are 4 times 5. And then there's 2 of them that are 11 times 4, okay? What you have right here matches this equation I have right here in the margin that I'd like you to put in your green formula sheet. Surface area of a rectangular prism, otherwise known as a box, okay, is 2 times your length and width, 2 times your length and height, plus 2 times your width and height, okay? Now, my length and width were 11 and 4, so this was my length and width, okay? 4 and 5 were my width and height, and 11 and 5 are my length and my height. All right, I just kind of want to show you that when you look at my equation down here, my length and height are this middle one, my width and height are the last one, my length and width are the first one. It really didn't line up exactly with that formula, but I got the job done just in a different order. So visualizing it, I could look at my 6 rectangles and I could do that, or I can just plug and chug straight into this formula. And that would have given me 2 times the length, which is 11, times my width, which was 4, plus 2 times my length, which is 11, times my height, which is 5, and 2 times my width, which was 4, times my height, which was 5. So you can see it's really the same thing. So 4 times 11 is 44, doubled is 88. 5 times 11 is 55, doubled is 110. 5 times 4 is 20, doubled is 40. And when I add all of those together, I get a total of 238. And it'll be feet squared, okay, for my surface area. All right. Again, it's a formula. It's a long one. Some people are like, I can't remember it. Well, look carefully. What I did is I used every number twice, okay? 11 with the 5, and then 11 with the 4, and then 4 with the 5. So I used each one twice, just never with the same thing twice. Okay. Next one. I have a surface area of a right cylinder. Okay, the same idea goes for this cylinder as we just used for our prisms, okay? I want you to think about a cylinder. I have a circle on top, I have a circle on the bottom, and then I basically have this soup label in between that goes around the cylinder, and it's a rectangle, okay? It's the label of a soup can. That's really what is that surface there, okay? So what I have are two circles, okay, and it says 2 big B. Well, I don't like to say big B because I know those are always circles. They never change on a cylinder, and I find the area of a circle with pi r squared. So there's 2 of those circles that are pi r squared. All right, they have C times H. Instead of perimeter times H, they have C times H, and C stands for circumference. So circumference, so here's my height, and this soup can label is as long as what it takes to go around the circle once, which is the circumference. So don't forget the circumference is 2 pi r. So it's a rectangle, but its dimensions are 2 pi r times h. Okay, that is the formula for the surface area of a cylinder. So I'm going to put it here. Surface area, if I was in class, that would have popped up real pretty like that, but sometimes it doesn't work that way. Okay, erase. Here we go. Surface area of a cylinder is going to be 2 pi r squared plus 2 pi r h. And that covers both the circles on the ends and then that soup label in the middle. You'll notice I have 2 things to plug in, a radius and a height. That's all I need to plug in, and it'll plug and chug and solve it every time. So on my next cylinder down here, find the surface area. It looks like I have a radius of 4. I have a height of 5, okay? One thing I want to tell you before we start doing the work is leave in terms of pi, okay? What this will do is save you a lot of work and allow you to do very little with a decimal. Sometimes we don't even need it, okay? Get the decimal at the end. Okay, so here we go. We're going to plug in the radius of 4, so 2 times pi times the radius 4 squared plus 2 times pi times the radius of 4 times the height of 5. All right, we're going to do the math here. 4 squared is 16 times my 2 is 32, and I leave that pi. 4 times 5 is 20 times 2 is 40, and I leave my pi. What's super nice now is these are like terms, 32 pi plus 40 pi. I add the outside numbers together, and I get 72 pi. That right there is my exact answer in meters squared. If I want to find the decimal now, I can go ahead and hit on my calculator 72 pi, and I get about 226.2 meters squared there, okay? So 72 pi, and by the way, that was using the pi button. If you do times 3.14, you get about 226.1, so it's not much difference, but you might say, wait a minute, I didn't get that decimal. Well, it depends if you use the pi button or 3.14. All right, plugging and chugging isn't too bad, is it? Let's do another one here. Find the surface area of a right cylinder with a height of 9 centimeters and a radius of 6. Round your answer to 2 decimal places. We'll do that at the end. So surface area, as soon as I see that for a cylinder, I'm going to write down 2 pi r squared plus 2 pi r h. The more I write it down, the more my brain's going to remember it. In for my radius, I'm going to plug in 6. In for my radius again, I'm going to plug in 6. And in for my height, I'm going to plug in 9. 6 squared is 36, times 2 is 72 pi. 6 times 9 is 54, doubled is 108 pi. And now because they're both pi, it's super easy. I can add those two, and I'm going to get 180 pi. And this is surface area. Anytime I deal with area, it's going to be centimeters squared. So there's my exact answer. I can go ahead and hit that on my calculator, and as a decimal, it's about 565.5 centimeters squared. Okay, write down the formula, plug through it. All right, let's go to our last page here. Find the height of the right cylinder shown, which has a surface area of 198.8 square millimeters. This is one of those, just a reminder that you write down your formula and you plug and chug every number you can until you're solving for what's missing. Okay, so they wrote down for me surface area equals 2 pi r squared plus 2 pi r h, and I plug in what I know. They gave me a surface area of 198.8. I plug in the radius. I see the radius is that 2.8. Couldn't give me pretty numbers, could they? Plus 2 times the pi times the radius of 2.8 times h. So the only thing I'm missing is the h. Okay, I can tell you right now, these numbers are not going to be pretty because I can see that there's no pi in the answer. So they've already multiplied out times the decimals. Okay, so I'm going to leave this 198.8. And because this is not pretty, I'm not going to leave anything in terms of, I'm going to just roll my decimals, okay? 2.8 squared times 2, run that number through, and I get 15.68. I'm actually going to do this too. I'm not even going to take, I'm going to take it times pi. All right, I'm going to make this whole thing 49.26, okay? Over here, 2.8 times 2 times pi, I'm going to make it, I'm just going to take out that pi part. I'm going to make it 17.59h, okay? So there's no good reason to keep this in pi since the final area wasn't in pi, so I'm just taking everything times pi. My job now is just to get that h by itself. So the first thing I'm going to do is take my 198.8, and I'm going to move this 49.26 over by subtraction, 49.26. And I'm left with 17.59h. Okay, remember we took care of that pi. All right, 198.8 minus my 49.26 gives me about 149.54 equals 17.59h. All right, one step left to get h by itself. I'm going to divide by 17.59. And it looks like I get close to 8.5. All right, and I notice all the squiggles. I am definitely rounding here, 8.5 millimeters for that height, okay? I'm going to be honest, I don't like this question as much because I'd rather leave my stuff in terms of pi and make cleaner numbers for you to work through, okay? But the key is if you know what variable you're looking for, slowly get the other things away from it until you have that variable by itself. All right, and number 3 is much more like I would put on a test or quiz for you, okay? And it's got some good math. All right, find the radius of a right cylinder with a height of 5 inches and a surface area of 168 pi square inches. I love that I see pi. So I write down my formula, surface area equals 2 pi r squared plus 2 pi r h, and I'm going to plug in everything I know. The surface area is 168 pi, and that pi is very important. Then I'm going to do 2 times my pi. What I don't know is my radius, so I leave radius squared plus 2 pi. I don't know my radius, I leave it, times a height of 5. All right, there's not a lot I can do here, and especially because I see I have 2 r's, one's an r squared and one's an r. Let's do the math I can. Over here I can do this. I'm going to leave this 168 pi equals 2 pi r squared. 2 times pi times r times 5. If I do what I can in my head, 2 times 5 is 10 pi r. Okay? What do you notice about all the terms here? Okay, you see an r squared and r, and you want to set it equals 0. Good plan. Let's move this 168 pi to the other side because we're looking at a quadratic, right? 0 equals 2 pi r squared plus 10 pi r minus 168 pi. All right. It's a quadratic. We can solve with the quadratic formula. We can solve it with factoring. Those are my 2 favorite ways. And you know my favorite way is factoring. What do you notice about all 3 terms? They all have a pi in them. And I wrote that one wrong. This is just 10 pi r. It doesn't have an r squared. And be careful, the last one doesn't have an r, so that doesn't help us. But how about 2 pi? Let's divide everything by 2 pi because I see everything is even and everything has a pi. All right, 0 divided by anything is still 0. 2 pi divided by 2 pi just leaves me r squared. 10 pi divided by 2 pi, the pi's cancel. 10 divided by 2 is 5r. On 168 pi divided by 2 pi, the pi's cancel. 168 divided by 2 is 84. All right, looks a lot more manageable. Anybody know factors of 84 that subtract to make 5? Let's see, 84, 1 and 84, 2 and 42, 3 goes in 28 times. Does that sound right? I hope that's right. 84 divided by 3 is 28. Yeah. 4 is going to go in 21 times. 5 does not go in. 6 will go in 14 times. 7 goes in 12 times. Wow, there's a lot of the factors. 8 does not go in. 84 divided by 9, I don't think that's going to work. Yeah, I think we have the list. Do any of them, remember to read this, do any of them subtract to make 5? Aha, that one right there at the end. So we can factor. I get an R and a 7, an R and a 12. Whenever we subtract, the larger number gets this middle sign, so 12 gets the plus, 7 gets the minus, and they equal 0. When two things multiply to equal 0, one of them has to be 0. So either R minus 7 equals 0, or R plus 12 equals 0. So if I add 7 over here, R equals 7. If I subtract 12 over here, R equals negative 12. Well, I can't have a radius that's negative, so that's not going to work. So it looks like my radius is going to be 7 inches on this one. All right? So some good algebra on that one to practice. All right. That is my notes for 12.2. I will tell you, we really have not done a lot with the prisms. So I really need you to practice on your homework. Really stop yourself and find what's my big B, what's my P, what's my H, and then plug through the formula. Always stop yourself and say, what's the big B? How do I find its area? Find that using rules from chapter 11, and then find your P, find your H, and go from there. Okay, so you are looking at your 12.2 worksheet, okay, and working through that. Let me know if you have any questions.